Hello, are you ready to learn about computer programming? My name is John McClellan, and I work at Reading High School. I teach a variety of subjects, but I'll be talking about my wonderful Math Models class and their journey through the challenge-based learning and engineering design process. My students picked up that they were going to focus our attention on 21st century programming. After two great hooks playing mobile games and watching coding videos, students naturally began asking great essential questions. How are computers organized? How do computers and humans interact? How do computers learn or evolve? What types of input do computers take? After a great discussion, the class thought the best way to summarize these questions into one thought: how do computers think? I challenge my students to build an AI in computer software scratch that can navigate through the maze. What you see now are some of their final results. What was great about the challenge is that the students wanted to build their own maze instead of having me provide them.
What instructions are needed for a computer to operate?
Great guiding question. We were able to answer this in our second lesson, following the big idea. We talked about how variables worked and how to plan with pseudocode.
What purpose does binary serve?
Well, in the next activity of the same lesson, we learned how we can encode information in binary numbers by reading your mind. We also saw how this Boolean logic applied to loops and flowcharts.
How does Scratch work, and what is its syntax?
Don't worry, we have some great tutorials in the next lesson provided for us by code.org. We're also able to build our own version of Flappy Bird with drag and drop code. These students did a great job in the next lesson, which involved taking on the challenge. First, students restated the challenge and gathered some research on maze building and navigating from the web and their previous tutorials. Next, they were asked to close their Chromebooks and write down 3 strategies for their code design and to select their best pseudocode. Once they were approved, they could implement their solution by converting their pseudocode into Scratch syntax. The coding process allowed for instant evaluation, depending on how well their program ran. Refinement of their process happened fluidly, sometimes taking quick fix in functions, but other times it required a complete overhaul in strategy. As you see, these students did a wonderful job communicating throughout the process. Part of the students' motivation throughout dealt with the understanding of ACS. A standing for applications, of which this idea has many in coding and debugging. Next, C stands for careers. Our hook video mentioned the true need for coders for our future. Finally, S stands for society. In our modern world, the next war might very well be fought in front of a computer screen. I want to thank all those individuals who helped and were part of the RET program this year. I also want to thank the National Science Foundation in conjunction with the University of Cincinnati for making this unit possible. I'm happy to say that this unit has helped foster growth and knowledge for my students.